All right, the last thing we have to do this semester is the law of cosines. And like the law of sines, it helps us find missing parts of oblique triangles. And oblique triangles means what?
Two sides and the angle.
That is any triangle in the world. An angle, a triangle that doesn't have a right angle. Any triangle that's not a right angle is an oblique triangle. So we use the law of sines to find the missing part under certain circumstances. What do we have to be given in order to use the law of sines?
Two sides and
Ratio of one angle and a side opposite it. You give me that one complete ratio and I can use any other information you give me to set up another ratio, and then I have a proportion, and then I can finish solving for the missing sides. And the thing that's kind of a nuisance about law of sines is that case, that ambiguous case, where sometimes you get no triangle exists, sometimes you get just one triangle, and sometimes you get two triangles. But still, we can use law of sines whenever we have that one complete ratio. Well, you can tell looking at our first example today, we're not going to be able to use the law of sines on that. We're given angle A, side B, and side C. So we just don't have the information we need to use the law of sines. And that's why there's a law of cosines. If A, B, and C are the measures of the angles of a triangle, and lowercase a, b, and c are the lengths of the sides opposite these angles, tell me if you want to memorize these formulas. A squared equals b squared plus c squared minus 2bc cosine A. And then it's first two cousins. No, I don't want to memorize that. I don't want to memorize that, but it didn't take me 3 or 4 problems before I had these words memorized. So these words are what you need, not those formulas. The square of a side of a triangle equals the sum of the squares of the other two sides minus twice the product, twice their product times the cosine of their included angle. Yeah, you're going to be fine. Let me show you how easy this is. If you start out on the left-hand side with side A squared, then on the right-hand side, you're going to have cosine angle A. If you start out with the left-hand side being b squared, then on the right-hand side, you're going to have cosine b. And if you start with c squared, on the right-hand side, you're going to have cosine c. So you remember that letters don't matter here. So let's just talk about the first one. If we have a square on the left, then we're going to have the sum of the squares of the other two sides, the b squared plus c squared, right? Minus twice the product of B and C, and then cosine of whatever angle is opposite that side on the left-hand side. It really doesn't take 3 or 4 of these until you just get those words in your head, at least long enough for the test. And if you forget it a year from now and you need it, you Google it. You know there's a law of cosines. You might have to look it up to remember exactly what it is. You just need to be aware that it exists. I think this is a cool discovery over here to the side. What happens to the law of cosines using that third form, c squared equals a squared plus b squared minus 2ab cosine c, if c is 90 degrees? What would that all boil down to if c was 90 degrees? Yeah. Degrees is what? 0, and 0 times a times b times 2 is 0. So that last term is gone, and you just have what famous theorem?
Pythagorean.
The Pythagorean theorem. So the law of cosines works, as does the law of sines, on right triangles as well as oblique triangles. You just don't have to use either of those for right triangles. All right, so objective 1. Our goal in both of these first 2 examples, or whenever we're using the law of sines, if we use the law of sines, we're going to have to, after that, use the law of, nope, I started that sentence wrong. Let me start it over. If we use the law of cosines, to find a missing part. Then after that, we're still gonna have to use the law of sines. So we want to be deliberate about what we find with the law of cosines to avoid that ambiguous case. We don't want to be in the situation where, well, maybe there's one triangle, maybe there's two. If we're wise about what we find with the law of cosines, then we'll never encounter that ambiguous case in the law of sines. And I'll tell you why. All right. When I see this, solve the triangle, and it's not a right triangle, the first thing I always ask myself is, can I use the law of sines? And we've already said, no, I don't have the information I need for it. So when I'm going to use the law of cosines, I'm going to first find the angle opposite the given angle. That's really all I could find first. If I'm given angle A, side B, and side C, then the third side is the only thing I could find with the law of cosines because it's the only angle that I have. So if I want to find A, then I'm going to start out with A squared on the left-hand side. And on the right-hand side, I'm just going to say those words to myself. Not a formula, but the words. The square of one side is the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle between them. Again, if you have A square on the left, you're going to have cosine A on the right. And then it's just plug some numbers and solve for A. So I'm going to go ahead and take the square root of both sides so I don't have to rewrite this long expression again. A is the square root of B squared plus C squared minus 2 times B times C cosine of the angle between them. Now, can I find an exact value for that, or would I have to find a decimal approximation? I could find an exact value because I could tell you exactly what cosine of 120 degrees is. My answer would still be irrational, square root of something, but I could find it exactly. I think the directions here actually say, did I write down the directions? I didn't write the directions, but based on what I wrote for my answers, it looks like we're rounding everything to whole numbers. So if you punch that on the calculator, I got it to be darn close to 13. And that's the length of a side. So it's not degrees. You don't know what the units are.
How come it's not degrees? We're using degrees opposed to minutes.
But A is the length of a side. The length of a side is not degrees. I have my calculator in degree mode to punch that. But once I punch that, that's just a number.
How can you change modes in the middle of function?
You're not changing modes. If I say what's cosine of 120 degrees, you go, that's 90 and 30 cosine would be negative a half. Yes?
Yeah.
Cosine of 120
yeah.
degrees is negative a half. Negative a half is not degrees. Negative a half is just a number. It's the ratio of two sides of a triangle. It's adjacent over hypotenuse. So once you take the cosine of 120 degrees, you've done the trig. It's not degrees anymore. Oh, cool. Okay, I didn't expect that, but I'll stare at Carrie until that frown goes away.
Sorry, I'm still confused.
Yeah, I'm trying to think what else I could say to help. If I say what is cosine of 120 degrees?
No,
You-
I understand that. I just don't understand the whole calculator.
I have my calculator in degree mode because I need to enter cosine of 120 degrees. But after I've gotten the value negative a half, if I just ask you, hey, Carrie, what is this? 7 squared plus 8 squared minus 2 times 7 times 8 times negative a half. You're not thinking degree mode or radian mode. That's
Oh, I'm
just-
just gonna solve.
yeah, you're just evaluating an algebraic expression.
Okay,
Okay, yay.
that's what I thought you said that we had to put it in radian.
No. I didn't mean to say that. I don't think I said that.
No, I think I thought you said. that,
Okay.
but you didn't say
Okay, all right.
that.
So that's just, it could be miles, it could be centimeters, it could be any measurement of length. And it turns out to be exactly 13. I was not expecting that. All right, now here's where, like I said, we didn't really have any choice about what we found first. We had to find A first because, or side A, because angle A was the only angle we had. Miss Nicole?
You have to do plus or minus 13 or.
No, what you're thinking, and let me show you, when I take the square root of both sides of an equation. Oh, okay, because I am taking square root of both sides of an equation right here. A negative doesn't make sense for the length of a side of a triangle.
Oh.
Okay, so that's why you don't need the plus or minus. All right, so like I said, we didn't have any choice about what we found first, that side. But once we find that A equals 13, look up here at my guideline number 2. I want to use the law of sines to find the angle opposite the shorter sides, because that angle has to be acute. And if it has to be acute, then I've avoided the ambiguous case. Think about it. The angle, at most, a triangle can have one obtuse angle, correct? Can't have two obtuse angles. So at most, it can have one. If we find the angle opposite the shortest side, it has to be acute, because there can only be one obtuse. And if we know it's acute, then we don't have to go, oh, there may be two triangles. So the next thing we're going to find is angle B, because side B is the shortest side. All right, set me up my proportion to find angle B. If I want sine B in the numerator, what's in the denominator? Side angle
Oh,
B.
we're doing this.
Yeah, now we're using the law of sines. Sine of B over 7 equals what? Sine of 120 degrees over 13. And when you multiply both sides by sine, actually, I'm just going to go ahead and take 2 steps here. After I multiply by sine, or 7, excuse me, after I divide, slow down. After I multiply both sides by 7, what am I going to have to do to solve for B? Inverse sine. So I'm going to go ahead and say B is the inverse sine of 7 times sine of 120 degrees over 13. Yes. I don't, surely that doesn't come out to be exactly 28 degrees, does it? Okay, it's darn close to 28 degrees. See, yesterday when we were using the law of sines and we came up with this argument being a number that's less than 1, we said, oh, the angle whose sine is this number is 28 degrees in the first quadrant, but there's another in the second quadrant. Right? Or technically we said there may be another in the second quadrant. Well, now we don't have to deal with that case because we know the angle opposite the shortest side has to be in the first quadrant, has to be less than 90 degrees. All right. We were given 3 parts. So far we have found 2. What's the other one? Angle C. Angle B was 28 degrees. And now we're looking for angle C. How can we find angle C? As long as we're not working for NASA. Now, if we're working with NASA, for NASA, we're either going to have to use this exact expression for B, or we're going to have to use the law of sines again. If we're not working for NASA, and on the test, you can play like you're not working for NASA. You can just find C by 180 degrees minus your other 2 angles, 28 degrees and 120 degrees. And that is 32 degrees. Yes, ma'am.
Okay, so if we start out using law of cosines, but you're never gonna have an ambiguous case?
If you make a wise choice about what to find first with the law of sines, because of this, if I had not found the angle opposite the shortest side, if I hadn't found angle B first, if I had found, well, in this case, I already knew the angle opposite the biggest angle. But if I had not known angle A, I wouldn't have wanted to find it by the law of sines, because then I'd have, oh, it could be this in the first quadrant or that in the second quadrant. As long as you follow these guidelines, then you're not going to encounter the ambiguous case.
Just use the law of sines, you've gotta make sure it's not.
Right. All right. The only other scenarios, the only other 3 things that we could be given and told to find all the missing parts is 3 sides. Tell me what you're thinking, Jackson.
If we did the straight law signs, would it change our answer?
Tell me how I would have done that in this example. How would I have used the law of sines? Well, I couldn't. That's why I had to use the law of cosines. I didn't have that one complete ratio of an angle in the side opposite it. So that's the only time I use law of cosines, when I don't have the information I need to use law of sines. And so what about that second example? Could I possibly start with law of sines on it? Nope, I don't have any angle. I just have the 3 sides. So when I'm solving a side triangle, I'm going to use the law of cosines to find the biggest angle. Remember, there can only be one obtuse angle in a triangle. And if I find the biggest angle with the law of cosines, I don't have to worry about the other 2. Oh, maybe 2 cases, maybe ambiguous. All right, so when I'm given 3 sides, I'm going to first find the angle opposite the longest side. And in that case, which angle am I going to find first? B. So if I want cosine beta on the right-hand side, what do I have to start with on the left-hand side? B squared. All right, help me with those words. B squared equals sum of the squares of the other 2 sides minus twice the product of those 2 sides times cosine of an angle between them. Are you starting to be convinced that this isn't going to be as hard to memorize as it first looked? You just practice those words a few times, they get in your head. You could either plug in the numbers first and then solve for cosine beta. Or you could solve for cosine beta and then plug in the numbers. Doesn't matter which one you do. Let me plug in some numbers here. If B is 10, I have 10 squared equals 8 squared plus 5 squared minus 2 times 8 times 5 cosine beta. Now, what calculator function or what function am I going to have to use to find beta?
Inverse of cosine.
Yeah, I'm going to have to use inverse cosine. For some reason I'm calling that beta instead of B. I'm just feeling kind of Greek today. Can you see what I would have to do to isolate the cosine beta? Subtract the 64, subtract the 25, and then what? Divide by -80, and then you'd have the cosine B by itself. So I'm going to take a huge leap here and see if you're okay with it. If not, I can put in middle steps. But I'm going to go ahead and say B will be the inverse cosine of exactly what you just told me to do. I have 100. I need to subtract the 64, subtract the 25, divide by the -80. Does anybody need to see middle step? Yes, Miss Ellie? That pencil drop means show me a middle step. Would you like to see it? Okay, all right, then I'm gonna come out here and put it to the side, Miss Ellie. Here's your middle step. 100 equals 64 plus 25 minus 80 cosine B. All I did is square everything that needed to be squared. You're okay now? You can take the rest of that leap. Subtract the 64, subtract the 25, and divide by the -80. Okay, good. You can make that a little bit easier to punch on the calculator. 100 minus 64 is 36. 36 minus 25 is 11. That's cosine, inverse cosine of -11 over 80. And what'd you get that to be? Okay, I think the directions still say round to the nearest whole number. So that's 98. And because B is an angle, not a side, we need to give the units on it. And Ms. Haley said it's degrees, 98 degrees. Now, let me make sure you understand why, when we get to the law of sines now, we don't have an ambiguous case. What kind of angle do we know B is? It's obtuse. And how many obtuse angles can a triangle have? Only one. That means whatever I find after this, the other two angles have to be acute. And that's why I don't have to worry about the ambiguous case. I avoid the ambiguous case if I find the biggest angle first. All right, now that I have one of my angles, I have angle B and I have side B. So what could I find next? I have side C. I could either find angle A or angle C. Any, many, miny, mo, doesn't matter which one you find first. You want to find angle C first because Rachel said so. Then we could say sine C over 5 equals sine of 98 degrees over 10. Just multiply both sides by 5 and take inverse sine. C would be inverse sine of, I can reduce that 5/10 to a half. Half sine 98 degrees. And what'd you get for that? Yeah, I got 30. Mhm. 1/2 times the sine of 98 degrees, or you could punch sine of 98 degrees divided by 2.
That's what I did. I did 98 divided by 2.
Did you do sine of 98? Or just
Not the
98?
negative. Oh, I didn't hit sign. You're right, there it is.
Okay.
Yeah, that could be it.
Okay, I understand what you said about, there only be one obtuse angle.
Mhm.
If that's true, then why do we have to solve for the shorter side in example 1?
Because in example 1, the only thing we could find first, the only angle we were given is A. So we didn't have a choice about what to find first. We had to find side A because A was the only angle we had. Now, I'm not finished with that because so far so good?
Yeah.
Okay, so we didn't have a choice. In the step where we use the law of sines, we said the angle opposite the shortest side always has to be acute. If we can narrow it down to where we're definitely looking for an acute angle, then we don't have to worry about the ambiguous case. We're looking for an acute angle here because it's the angle opposite the shortest side. And we're eliminating the possibility of getting an obtuse angle here, because if there was an obtuse angle, we already found it with the law of cosines. Take some wrapping your head around.
Isn't the 120 obtuse too?
Yes, but it's the only obtuse. I didn't find A with the law of sines. I found A with the law of cosines. Because I knew that, because it was the only thing I could find with the information I was given. I see you, Madison, give me one jiffy. I have to study those 2 boxes to make sure I'm finding the right thing first, so that I don't have that ambiguous case. And with a side angle side triangle, there's only one thing you can find first, but the thing you want to find next is the smallest angle, because it has to be acute. With side, 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 you want to find the biggest angle first, because that guarantees the other 2 have to be acute. Madison?
So if you do it wrong, could you get ambiguous?
Yeah, yes, you wouldn't know yet if you had an ambiguous case. You would have to try to find both triangles, and it would end up that you would end up eliminating one of them.
So there's always only one.
Yes. Yes. Haley, did I see you have your hands raised too?
Yeah, but
Okay. Yes. Yes. Did we find all the missing parts? Did we finish checkpoint 2?
I believe.
Yes, we have all
No,
3.
we didn't get the A.
Oh, you're right. We have B is 98 degrees, C is 30 degrees. If we're not working for NASA, how can we find A?
Sure.
Yeah. 180 degrees minus 98 degrees minus 30 degrees. And if we're working for NASA, we can't use a value that we've already calculated to find another value. All right. So far, so good. Gonna go to sleep tonight going the square of one side of an oblique triangle is the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the angle between them. That's what you say tonight instead of now I lay me down to sleep.
Sure.
Okay. Whew, can we stand two more? This is our last two-word problem until the test.
Word text.
Whatever the review says, and I think it's only two. It is whatever the review says. I think it's just two. It may be just one. Either one or two. All right, so let's play like we don't know we're in section 6.2 doing the law of cosines. We just see this problem. We have to sketch it out, label what we can, and then figure out what we have enough information to use. If we have one complete ratio of a side and an angle opposite it, we'll use law of sines. Otherwise, we'll have to use law of cosines. Remember your bearing notation? It's always with respect to the north-south line. You're either east, let me turn around, I'm pointing the right way. You're either east of north, which is to the left of up, west of north, which is to the right of up, or east of south, which is to the right of south, west of south, to the left of south. Okay, let's try to draw it. I really should use a pencil. Pencil, got one. Okay. Airport A and travels 580 miles to airport B on a bearing of 34 degrees east of north. Since my plane is headed north, I'm going to put my airport A down here so it has room to go north. And here's my little north-south line through airport A. And here's my east-west line. That 34 degrees east of north means 34 degrees to the right of that north-south line. Now, where's the 34 degrees? Is it this top angle or this bottom angle? Yeah, it's with respect to the north-south line. So this is the 34 degrees right here. But then that makes it easy to figure out what this one is. Yeah, because the two are complementary. That has to be 56. Is that right? That has to be 56 degrees right there. All right, the plane is going to go 580 miles in that direction. It's going to get to airport B. And airport B has its own north-south line and east-west line. B, the plane is going to go 400 miles on a bearing of 74 degrees east of south. You draw 74, a line that's going 74 degrees east of south. Here's south. 74 degrees east of that might be here-ish. It's only going 400 miles in this direction, so I'm going to make that side look shorter than the other side. And then it's at airport C. That made sense so far? Did you stay one step ahead of me? Good. We're trying to find the distance from airport A to airport C. So this is what we're trying to find. I'll call it X. I forgot to label my 74 degrees. Do you see where that 74 degrees should be? Right here. 74 degrees east of south. So really, right now, we only know one interior angle, the 56 degrees, and part of the other interior angle. Be what?
34. And then add together
Tell me why you're saying 34. You're right.
because the.
That good old, my favorite, only theorem I remember from geometry is if two parallel lines are cut by a transversal, then alternate interior angles are
Yeah.
equal. If this, let me highlight my two parallel lines cut by a transversal. Turn it that way and you can see them. If that's 34 degrees, that has to be 34 degrees. I'm so proud of you. You've learned a lot, sister. So now we know two of the interior angles. We know that this big one right here is 108 degrees. When I'm solving for the missing part of an oblique triangle, first thing I always ask myself is, do I have what I need to use the law of sines? Yeah, why did I have to use the law of cosines on this one?
Wait, no, but doesn't cut it exactly.
I know the 56 degrees and the side opposite it is 400.
But it doesn't cut it exactly. The 56.
Yes, I see it now. Yeah. This 56 degrees is not,
So what would be 36 on?
Side A is 400, not 580, so it doesn't come all the way back down to make a straight line. Back to everybody A. So it couldn't be.
I'm sure you're right. It's not clicking in my brain yet, and I can't make things click. I can't listen and think at the same time, so give me 1 second. This is definitely 108, and X is the side opposite it. If we know, yeah, I'm not seeing it. If we know the 5, if we know this angle, which it would be easy to find. 16, because that's 164. Yeah, that's 16 degrees.
That, it can be. The 56 isn't the angle. Because it doesn't go exactly east of airport.
Okay, it's not going all the way down to this line.
Yeah. So it can't be 56 degrees.
Oh,
But we're not calculating it, cross on the C. Because we're getting the 16 from the 74.
Getting the 16 from the 74. We're getting the 16 from the 108 and the 56 and the 16.
Can I go back?
I just did this problem before y'all came in to make sure it wouldn't stump me. Hold on. I just saw it. Just have to be quiet for a minute. I see why. Here's the east. We know that this is the 56. Not that little interior angle right there. If this was 34, then complementary with that, this whole thing right there is 56. So we don't know what this little different color pen. We don't know what this is. The 56 is that big angle. Okay. So that's not,
That's not.
not 16. Okay. Whew. So what do I know? Do I know one side and an angle opposite it?
Yeah.
No.
No. No, that's why we can't use the law of sines. So to use the law of cosines, to find x, if I want x on the left, what am I gonna have on the right? Cosine of 108, cosine of the angle opposite it. So I could either start my equation x squared equals blah, 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 or I could go ahead and take the square root of both sides and say x is the square root of the sum of the squares of the other two sides. I put degrees. Because I meant to put square. 580 square plus 400 square minus 2 times 580 times 400 cosine of the angle opposite x. Got it? What did I get that to be? Darn close to exactly 800 miles. Make sure you take the square root. It's 799.99. Yeah, almost 800. Yeah, and 79.99 to the nearest tenth would be 800. 800.0. How could we be different? 580, 400 minus 2, those 908. I don't know why.
Me too.
Oh, okay, so nobody got 799.99. Okay, then I was just having a moment when I wrote that down. You said 0.86. And so to the nearest tenth would be 799.9. Okay. $799.9 miles. All right.
Boom.
Yay. One more. Well, I'll tell you, just in case we don't have time to get to Heron's formula, it's a formula. If I give you a formula, you plug numbers into it, you can do it. It's a no. I looked at the test and the review. It doesn't have area on it. You have one of these in the homework, but you don't have an area problem on the test. Yeah, so you. No. Yeah, this would be, this would be easy. Given sides A, B, and C, here's how you find the area. Wait, first you have to find S is 1/2 of the perimeter. You find 1/2 of the perimeter, you use that for S, and then you plug in sides A, B, and C, and that will give you the area of a triangle given its 3 sides. Would you like to do that? No. Okay, let's see if we can do our last word problem of the semester. Okay. The figure shows a 200-foot tower on the side of a hill that forms a 5-degree angle with the horizontal. And I was so nice that I gave you a picture of the hill, a picture of the horizontal, and I even put the 5 degrees in the right place for you. The hill makes an angle of 5 degrees with the horizontal. All right. There is a tower on the side of that hill. I'm just gonna kind of draw in the center of that tower is down to the horizontal. And the tower's 200 feet. I labeled that for you. Find the length of the two guy wires. That's these two wires tightly anchoring the tower so that it stays perpendicular to the horizontal. Are those two guy wires going to be the same length?
No.
No, the one attached downhill is going to be longer than the one attached uphill. So let's call them X1 and X2, and we expect X1 to be bigger than X2. Find the length of the two guy wires that are each 150 feet from the tower's base.
So what can it be?
Yeah. I'm gonna label each 150. I don't know yet if I'll need the 150 or the 300. But if I need the 300, I can get it easily. 150 plus 150, round to the nearest tenth of a foot. Okay. Do I know any angles?
Just.
Okay, this is a right angle here. And if that's 5 degrees, what does this have to be?
85.
85 degrees. And what does this have to be?
90.
So far, so good?
Because you add 5.
85 and 95 are supplemental. They form that straight line.
Oh, okay.
So far, so good. Got everything labeled? Do we have what we need to use the law of sines?
No.
We know two angles. Hold on, don't say anything for one thing, that I have a different idea. Okay, never mind. I know why that idea was invalid, so I'm not even gonna say it out loud. What can I do? What can I find?
You got two sides and a.
I can. I can find X1 by using the, let's see, if that's. Complete thought, please. Oh, this is 200. I'm gonna break out that one triangle. It's kind of hard for me to see. But here's the one triangle that I have. This is 150, this is X1, and this is 95, 95 degrees, and it was the other side that I wasn't seeing for a second. The height of the tower is 200. Oops, there we go. That's one of my two little triangles formed by the left guy wire. So if I want to find X1 by the law of cosines, I would need to say X1 squared equals blah, 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 or I could go ahead and take the square root of both sides and say, tell me the rest of it. X1 equals square root of 150 squared plus 200 squared plus the product of the other two sides times cosine of the angle between them. Oh, this is the angle that's between the 150 and the 200. So I punched that and got approximately 260.2 feet. Anybody second that?
Yeah.
Okay. Two is gonna be the same thing except for cosine of 95 degrees. On the right-hand side, we have cosine of 85 degrees. X2 is gonna be the square root of 150 squared plus 200 squared minus 2 times 150 times 200 times the cosine of 85 degrees. Didn't we say X2?
It's gonna be shorter.
No, it's shorter. It's a shorter distance to where the uphill anchor is attached to the ground than where the downhill anchor is attached to the ground. All right. Crazy fast, 60 seconds or less. Find the area of the triangle given these three sides with Heron's formula. We need to first find S. S is half of the perimeter. The perimeter is what you get when you add all three sides together. So 6 and 16 is 22 and 18 is 40 and half of that is 20. And the area is the square root of S, which is 20, times S minus A times S minus B times S minus C. Square root of 20 times 14 times 4 times 2 is 280 times 8, whatever that is. Square root, I got approximately 47.3. What's the units on that? Since my sides are given to me in meters, the area would be square meters. And I'd be a little bit sad if I wasn't getting on a plane for Ireland Wednesday. So sad. What you need to do, what's tomorrow on the calendar? Review day. So you have the review that tells you there's going to be 17 problems. Only one of them is an application of either law of sines or law of cosines. No area problems on there. I gave you all of the problems together from the chapter 5 and chapter 6 review. Finally, this is what I will hand you when you come in to take the test Thursday. It's got instructions for the test, like turn off your phone, and then it has your formulas. The formulas are exactly what I told you I would give you. Sum and difference, double angle. You don't have a power reducing problem, half angle. And I left blanks to put the three Pythagorean identities just to have to look at. All right, see you tomorrow.
Oh,
Yes.
maybe getting on a plane to go to Ireland
Yes.
Wednesday,
Yes.
but I'm getting in a car driving to 29
That'll be nice too.
Thursday.
Yay, good for you.
We're gonna go on a cruise. There's gonna be a heated pool. We're only gonna be like 10-minute walk from the beach.